In Chapter 5, we're going to get into a lot of different topics. Today, though, is exponents. And then towards the end, we will talk a little bit about scientific notation, which uses exponents, so they kind of go hand in hand with one another. Okay, exponents. Exponents, we're going to talk about a lot of different exponent rules, and these are some things that you've seen before for the most part, some of the different rules. We're going to, early on in the semester, we talked about like using it as part of like PEMDAS, right? Doing by order of operations. And we'll see a little bit of that today, but today is more of like the exponent rules. The one thing that I would say is if we have a number like -8 and we square it, this is different than this. So when we have exponents, we've got to be really careful about the notation that we have with those exponents. Here, we're taking the entire thing and raising it to the second power. Here, only the 8 is being raised to the second power. So that'll kind of change how I put it in my calculator as well, right? So in this case, you would want to put parentheses around it because it's really -8 times -8, which is really positive 64. Okay, so this one would get us to a positive answer. This would be the same thing as this, where the only thing that's being squared is the 8 itself. The negative is not really attached to the 8, so we're only going to square the 8, and my answer here would be -64. And unfortunately, a lot of the calculators, when you put it in, for instance, if I had x squared, and I said x is -5, what a lot of people will do is they'll put it into their calculator like this. So which way do you think it should be put in? Should it be with parentheses or without? It should be with, right? And the reason why is because we're squaring whatever x is. X is -5, so this would be the way we would want to put it into our calculator. So even though they may not have parentheses, right, you need to know x is -5, so we're squaring whatever x is, so we're really squaring -5, which would become 25. Okay. So yeah, it takes a little bit longer to put some parentheses in our calculator, but parentheses are going to be absolutely critical on a problem like that if we were to evaluate it. And we kind of talked about that a little bit when we did PEMDAS and all of that. Now remember, if we have like -3 to the 5th power, what is -3 to the 5th power? And you can use your calculator if you want, if you don't know it. It's early in the morning. I don't expect you to do that in your head. What'd you get? -243. Does that sound right? Okay, now what if we did this without the parentheses? It's the same thing. So why is this one the same answer when this one is not the same answer? Because it's an exponent of 3, right? Or in this case, 5. If my exponent is odd, then the negative will stay all the way through, okay? If my exponent is even, then a negative and a negative would in turn make that positive, okay? So we really got to pay attention to if our exponent is an even number versus an odd number. That changes a lot of things as well, okay? So all of those things are things that we've kind of talked about early on in the semester. Most of the problems that we do today aren't necessarily going to have numbers that we're taken to a power. It's going to be more variables. Since it's algebra, we get to use variables. So we're going to have a bunch of different rules today, okay? And all of these rules are rules that I think for the most part you've seen before, but it's probably been a while since you've seen some of these. The names of each one of these kind of tells you what's happening. So the first one is what we call the product rule of exponents. And I'm not going to write of exponents on all of these. If I talk about it, I'm probably just going to call it the product rule, because all of these are dealing with exponents. So I'm not going to call all of these the product rule of exponents. I'm just doing it for this one. So whenever we have exponents, the product rule states this. If I have x squared times x to the fifth, and we call it the product rule because product means multiplication. What do you think our exponent is going to be? X to the fifth times x to the second. X to the seventh. That's right. Okay, and the reason why is because x squared is 2x's. X to the fifth is 5x's. If I put all of those x's together, I really have 7x's. So what we're doing there is we're adding our exponents. It doesn't matter what the variable is as long as the variable is the same on both. We could do the same thing for numbers too. If I had 4 to the second times 4 to the sixth, this would be the same as 4 to the eighth. Now, this would be one we could actually put into our calculator because our base is a number. If our base is a variable, we'd have to know what x is. But if our base is a number, we could put it into the calculator. But if we put it into the calculator, rather than doing 4 to the second times 4 to the sixth, we could just put in 4 to the eighth. It would be the same thing either way. Okay, if I see one like this, once again, it's a product, right? We're multiplying two different things together. This is not addition or subtraction. So a lot of times when people look at this, they're like, oh wait, those are not the same terms, because one's x squared and one's x cubed. They don't have to be alike, not with multiplication. When we get into addition later in the chapter, yeah, they're going to have to be the same, okay? If this is x squared and this is x cubed, we wouldn't be able to add or subtract them together. But that rule only applies for addition and subtraction. For multiplication, it doesn't matter, okay? So we're just going to multiply these two terms together. When I multiply them together, we're going to multiply the coefficients first. So we're going to multiply 7 times 2, which will give us 14. And we're going to take x squared times x cubed. And there's where we add the exponents. And that would be our answer. Hello? Yeah. Okay. Okay, so like Nikki, is that okay? Yeah, I could probably do that. Yeah. Okay. Is she here at all today, or oh? Okay. 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 Okay, perfect. Okay, all right, we'll do. Thanks, Lori. All right, let's do one more. This one's a little bit different. Let's go negative 9 m squared n All right, so all that's happening here is we just keep adding a little bit more and more, right? We started off with just a single variable. Now we have numbers. We have multiple variables. But everything, in order to multiply them together, they have to be the same base. They have to be the same bottom of the exponent. So we're going to start off with the numbers. And it's just a multiplication problem. So negative 9 times 5 would be negative 45. Finally show up. All right. I called her, and she said that she thought I needed it at the end of October. So it's a good thing I called. So if you haven't gotten yours yet, you might verify that. Okay. Might double check on it. Because I went back and looked at my email, and it said beginning of October. But I think she must have thought beginning of November. I don't know. Okay, so they, if you put that name down, it should be good. Yeah. Okay, thank you, Mr. Frederick. All right, so negative 45, m to the second, m to the third is going to be m to the fifth, n to the first, and n to the seventh would be n to the eighth, because we've got to remember that there's an assumed 1 on that end. And then the first parenthesis does not have a p, but the second one does, so it just stays p. And that's it. That'd be our answer. Okay, so that's what we call the product rule of exponents. Okay, the next rule. Is what we call the zero exponent rule. This one's pretty straightforward, right? Our exponent is going to be 0, just like it says. If I have any variable, let's say p raised to the 0, what do you think it's going to equal? It's just 1. It's just 1. Try plugging in a number, like 8. Try plugging that into your calculator. 8 raised to the 0. Should just be 1, yeah. Okay, and we'll talk about why here. When I have an exponent of 0, it'll always equal 1. It'll make a little bit more sense when I do the next rule, and I can kind of show you why anything raised to the 0 is 1. But since we haven't done the other rule yet, we'll talk about it here in just a second. But anything raised to the 0 is 1. Now, here is one where a lot of people struggle with this one. If I have 9 times n raised to the 0, n raised to the 0 is 1. 9 is not attached to the n here. They're two different things. So really this is 9 times 1, which is really 9. But if I did this, and if I have 9n, all in parentheses, and I raise that entire thing to the 0 power, my answer is going to be 1. Because everything is being raised to the power. So parentheses, like I said earlier, are extremely important today. Okay? Extremely important to what we need to do. Okay, so that's what we call the zero exponent rule. A few minutes ago we saw the product rule, so now we have the quotient rule. Okay, the quotient rule. Quotient means division. So when we had a product, we said we're going to add the two. When we have quotient, we're going to subtract the two exponents. So if I had y to the 9th over y to the 4th, I mean, one way you can do this, and we don't want to write out 9 or y 9 times. Same thing with y to the 4th. We don't want to say y times y times y times y. But if I have 9 y's on top and I have 4 y's on bottom, 4 of the y's are going to knock each other out. So how many do I have left on top? 5. So it'd just be 9 minus 4. Okay, and that's why because they knock each other out, because we're dividing them, 4 of the y's will disappear because they cancel out, and we have y to the 5th that's left. Okay, I told you that I would show you where the 0 rule comes from. If I have y to the 6th over y to the 6th, then when I subtract my exponents here, we get y to the 0. And based on what we just said here a few seconds ago, anything raised to the 0 power is 1. Well, the reason it becomes 1, and the reason why anything raised to the 0 is 1, if I take something and divide it by itself, what happens? What happens if I take 9 divided by 9? 1, okay? What happens if I take x divided by x? I get 1, right? Anything divided by itself is always 1. So when my exponents knock each other out, we have the same thing on top as we do on bottom, then all we have left is 1. Not 1y, okay? We don't want to include y on it, it's just 1. And the whole answer is 1. All right, 36x to the 8th over 4x squared. So once again, this is division, okay? And that's what you have to tell yourself. This is a division problem. If I covered up the x's here, I'm just dividing 36 by 4. It is not an exponent. It's just a number. So the first thing that I'm doing here is I'm just dividing 36 by 4, which is 9. And then I do my x's. I have 8 x's on top. I have 2 on bottom. So I'm going to end up with x to the 6th. And that's our answer. Okay. But you got to remember that it's division. All right. Well, last division one here. I'm going to give you all kinds of stuff going on here. Okay. Now, this one was pretty easy because 36 divided by 4 evenly. 18 does not divide by 30 evenly. So if I covered up all my variables here and I said I have 18 over 30, what would I typically do with 18 over 30? You'd what? Would we keep it as is? If I just wrote, if I wanted to simplify this, reduce it, right? So we got to find the highest thing that goes into both 18 and 30. So like I could take 2 out, but 2's not going to be the biggest thing I can take out. So we got to figure out what's the biggest thing that I can take out of both 18 and 30. 6. Okay. Anything bigger? I think 6 is it, right? So we're going to take a 6 out of both of those. So that leaves me 3 on top, 5 on bottom. We know that we're simplified because 3 over 5 doesn't simplify anymore. That is completely reduced. Okay, then we're going to look at our variables. T's are exactly the same thing, so they're gone. T squareds are out. I got 8 u's on top, I got 1 u on bottom. That's a really good way to think about it. If I have 8 on top and 1 on bottom, I have 7 more on top than I do on bottom. And then I have a v on top but no v on bottom. So there's my answer. Okay, so that's our third rule of the day. I won't tell you how many we have. It's not 10. Not close to 10. Okay. Negative exponents. There's a couple of ways that you can do this. For me, the easiest way to do this is to simply think about, especially if both of my exponents are positive, think about where we have more. I have 2 a's on top. I have 5 a's on bottom. Where do I have more a's? On bottom. How many more? 3. So the easiest way for me to do this problem is just write it like that. But the a's got to be on bottom because we have 3 more on bottom than we do on top, so 1 over a to the third. Now what a lot of people will do here is they'll use the rule we just did, right? And they're going to take 2 minus 5 because it's the same base. And they're going to say a to the negative 3. But we can never ever leave an answer with a negative exponent. It's not considered simplified. It's kind of like leaving an answer as 18 over 30. It's not simplified, it's not reduced. A to the negative 3 is, if you ever leave an answer with a to the negative power, it'll be wrong, okay? So never leave a negative exponent. So to get rid of the negative exponent, we flip it to the opposite side. If it's on top, we move it to bottom. If it's on bottom, we move it to the top. And that would be our answer. Because I could give you one like this. 3 over x to the negative 6. Since my x's start on bottom and they have a negative exponent, where do you think we're going to move it? To the top. Do I have to move the 3? No, it just stays on top. So my answer becomes 3x to the 6. Okay, what if I put a number to a negative exponent? You could put this in the calculator, but if you put this into the calculator, because my base is a number, I'm going to tell you right now, your answer is going to be a really small decimal. Okay? And you could math frac it and change it to a fraction, but I'm going to show you where that fraction comes from and why your answer is really small here. The negative exponent makes me flip this to the bottom. Now, when I flip it to the bottom, only the exponent becomes positive. Nothing happens to the negative on the 2. I flip it, the negative 4 becomes a positive 4. And if I take negative 2 and raise it to the 4th power, negative 2 times negative 2 times negative 2 times negative 2 4 times, what do we get? 16. So my answer is 1 over 16. Okay, and I tell you that because this is one you could do in your calculator, because my base is not a variable. My base is a number. And some people will be like, I'll just put that in my calculator. Well, that'd be okay, but your calculator will typically display that as a decimal. And then if you, you could math frac it. If you want to try that out, you can. You can change that decimal into a fraction. All right, there's 2 ways to approach this one. You can use either of the 2 rules that we talked about, or you can use your negative exponent rule here. Because this is a product, one way you could approach it is you could say, I'm just going to multiply these 2 together, and I'm going to add my exponents together. There's the product rule, and 3 plus negative 5 is negative 2. But I can't ever leave an answer with a negative exponent. So don't stop there. Because now that I have a negative exponent, I'm going to move it to the bottom. And I get 1 over t squared. And that's our answer. Okay. You could have moved this to the bottom right away. And then I would have t to the 3rd over t to the 5th. And then that would be another way that you could have done it. So what you'll find out is that there's more than one way to kind of approach some of these. You don't necessarily, you could use the product rule, you could use the quotient rule, you could use the negative exponent rule. There's a lot of different rules that could be in play here. So now we see numbers and we see variables. Once again, simplify it, reduce it based on what we have. Okay, so simplify negative 12 over 9. What goes into both 12 and 9? 3, okay? So we can take 3 out. 3 goes into negative 12, negative 4 times. 3 goes into 9, 3 times. So we're just going to reduce the numbers first, because they're not exponents, they're numbers. And then you look at the x's. Where do I have more x's at? Bottom, okay? And I have 4 more on bottom than I do on top. So we end up with x to the 4th. Okay, now here's the question. I have a negative on top. Does that negative need to move to the bottom? No. Because is it an exponent? No. Okay. I can have a negative number. I cannot have a negative exponent. So you got to remind yourself of that. Negative numbers and negative exponents are not treated the same way. If I have a negative exponent, I got to move it to the bottom. If I have a negative number, I can stay. When we get negative numbers all the time, right? Negative numbers are okay. Negative exponents are not okay. Okay. Next rule. You're going to be like, when are we done with rules, Mr. Ruda? I'm ready to be done with rules. Power to a power is a to the nth raised to the nth. So we have a power, an exponent, raised to another power, another exponent. In this case here, okay, the way I always learn this, and it kind of helped me remember it, so whatever, but way back when I was in high school, I remember my teacher said, pop me. Power over a power, you multiply the exponents. So power over the power, you multiply the exponents. So she would say, pop me, right? So that would be, we're going to multiply the exponents together. So this would be a to the m times n. We're going to multiply the exponents. So if I have t to the 3rd raised to the 4th, it would just be t to the 12th. That's it. X to the negative 5 raised to the 2. We're going to multiply them together. And can we leave our answer like that? No. So when I have a negative exponent, what do I have to do? Got to flip it. So 1 over x to the 10. Okay, so that one's power to a power. Next rule. The names pretty much tell you what we got going on here, okay? So here we got product to a power. So everything has to be raised to the power. So a product means I have two things that are multiplied together. It could be two variables, it could be a number and a variable, but two things that are multiplied together, and then we're going to raise that whole thing to a power. So we're going to raise a product to a power. Product means we got two things that are multiplied, and we're raising it to a power. Both of these things are raised to the second power. These are two individual things. So sometimes it might help just to cover it up. If I have 3 squared is 9. 3 is not an exponent. 3 is just a regular old number. 3 squared. A to the 4th squared is a to the 8. Because when I multiply, I'm going to multiply my exponents. Power to a power. That's my answer. Okay, negative 4 x y squared z cubed raised to the 5th. One thing at a time here. Negative 4 raised to the 5th power. Let's put that in our calculator. What'd you get?
1,024.
Okay, positive or negative?
Negative.
Negative, okay. Negative 1,024. X to the 5th, Y to the 10th, Z to the 15th. Do we have any negative exponents? Nope, we're done. We have a negative number, but that's okay. Negative numbers are okay. Negative exponents are not okay. Okay, and the thing you've been waiting to hear from me, the last property. Quotient to a power. Okay, and we may not get through everything here because we haven't talked about scientific notation here, so I'm going to stop after this property. A over B raised to the nth is going to be A to the nth over B to the nth. So if I have 3 over x squared cubed, we're going to raise everything to the 3rd power. So 3 cubed, remember it's not an exponent, so we're not multiplying 3 and 3 together, we're multiplying or raising 3 to the 3rd power, which is 27. And then x squared raised to the 3rd power would be x to the 6th. And that would be our answer. All right. I'm going to give you the assignment. We're probably going to have to cover a few things tomorrow. Tomorrow, I might make an adjustment. We might wait to do 5-2 on Monday. We'll maybe work on this a little bit more, work on the assignment, and then I might pass your quizzes back to you and let you maybe correct those tomorrow. Okay, so here's the assignment. You can start working on this. We haven't covered everything yet, but just so you have it before you leave today, if you want to start working on it, we'll probably have some time. Now, this is going to kind of blow your mind a little bit here. 10 to 125. There's 125 some questions in this section, okay? But we're going by fives, so don't freak out, okay? So we're going to go 10, 15, 20, 25. There's a lot of different questions, okay? I will tell you this about this section as well, guys, is that most of these problems, as opposed to last chapter, that some of those problems took us a while, some of these problems are just look at it, boom, there's my answer, but you got to know the rules. If you don't know the rules, then it makes it a lot more difficult, okay? So there's not a whole lot of partial credit involved here. You either got it or you don't. And so that's what makes this chapter kind of tough, okay? All right, so